Today I'm going to give a brief overview of the radiometer you're going to be building for your lab in radiometry. To begin with, we have a basic op-amp and resistor set to produce amplification from the photons that we're going to see from our photodiode right here. It connects to ground, and then it connects to pin 2 of our op-amp. Pin 2 we also connect through the resistor bank to pin 6, which is our output. An op-amp will do whatever it can to the output to try to make the voltages on the positive and negative ends, to pin 2 and 3, to be the same. We have a positive 9 and minus 9 volt source into the op-amp, and then we record our output across pin 6 to the ground. So over here is our op-amp. It's identified by either this bowl or a dot or both, depending on the op-amp. And then the pin layouts are as such: 1, 2, 3, 4, 5, 6, 7, and 8. Pin 1's an offset. We won't be using this for our radiometer. Pin 2 is our inverting input. That's where we have our signal from the photodiode. Pin 3 is our non-inverting input, which we set to ground. 4 is our minus input voltage. 5 is our positive input voltage. Pin 5 is another offset, which we won't be using. Pin 7 is our positive voltage, and pin 6 is our voltage output. So to build this, here's a brief example of what a completed radiometer will look like. And we're going to be using solderless breadboards. So here is a sample solderless breadboard. We put our ground usually on the black terminal, and then positive and negative to each one of these. It doesn't matter which one goes where as long as you know which one is which. The breadboards are connected in these strips here, along here. This gap here is not connected, and then same for all of these, and then the same ones for down here. These ones in the main bank go vertically. There is not a connection across this main gap. This is where you'll put your op-amp and switch bank, which can be, so op-amp, switch bank across there as shown. And here's just a basic diagram showing you what's connected. So if you see a line connecting it, current can flow between any of those pins. So I can't get one from anyone in W to anyone in X. I'd have to put some sort of bridge, wire, other components in order to get any sort of electrical flow through there. So just to quickly review what we have. So we have our ground to this pin here, and then that connects to this bank here. So any wire connected into this bank is on ground. So over here we have our output ground measure. We have our input to ground, and we're going from there to the non-inverting input onto the op-amp. I believe this one is going to be the plus 9 volts, and this the minus 9 volts going to the op-amp to power it. So we come in from our input here, and we go, this is also a line. Ignore that wire now crosses. Perhaps I should put a little jump there. So any of these resistors are all connected, and then depending on which switches you have flipped can tell you which gain you're going to get. And they're also connected down to here, going to the output and the output of the op-amp. And so over here we're coming from the input, so this is from our photodiode, and we're going there on the op amp. And I think that's a very brief overview of the radiometer.